Hello everyone, welcome to LD Talent channel. Today we are going to walk through an interesting coding problem. So we'll be merging a case sorted linked list into one sorted list. I'll be using C# for this implementation. So let's dive right in. So the question is, you are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. Then an example is provided here. The first example is called lists, and it takes a list of linked lists. Then we have the output, which gives us the sorted linked list. Then there's also an example 2 and 3, and we finally have the constraint that we need to work with. So imagine you have several linked lists, each of which is already sorted, as you can see here. This linked list 1 4 5, 1 3 4, 2 6, they are all sorted. So the goal is to merge all of this list into one single sorted linked list, which is what we have here. That is the goal. This particular problem is a common problem in coding interviews, and it can be quite tricky, but with the right approach it can become very manageable. So to merge k sorted linked list into one sorted linked list efficiently, we can utilize a main heap. Now, what's a main heap? A main heap is a type of heap data structure. It is one of the primary uses of the heap data structure for implementing a priority queue. This approach will ensure that we always have the smallest element at the top, making it efficient to merge the lists. Now let's walk through my implementation. First, we started by defining a class called solution, and we also defined a method called merge k list. This method takes an array of linked lists and returns a single list. And then on line 15, we are utilizing a priority queue. This priority queue that we've initialized on line 15, it will help us to efficiently manage and retrieve the smallest node from the list we are merging. That's why we initialized this priority queue on line 15. Now let's look at next code block. We have from 18 to 22. So using a for each loop, we are iterating through each linked list in our input array. So for each list, if it is not null, we add its first node to the priority queue. The queue is ordered by the node's value, which ensures that we always get the smallest node quickly. This is what our for each loop here is doing. So we are enqueuing the first node of each list using our for each loop. Why are we using an enqueue operation? This operation adds an element to the queue with a specified priority. So in our case, we are adding nodes from the linked list into the priority queue, where the priority is determined by the node's value. The priority queue ensures that the element with the smallest value is always at the front. So after we've enqueued the first node of each list using our for each loop, then we create a dummy head for our result list. That's what we are doing on line 24. We are creating a dummy head for our result list. This dummy head simplifies the process of building the new linked list. And then on 25, we also initialize a current pointer that will help us construct the merge list. Now the next block in our code is a while loop. As long as there are nodes in our priority queue, this while loop will keep running. And in each iteration, we are dequeuing the smallest node from the queue. And if that smallest node has a next node, we are enqueuing that next node. This is the way we will keep processing the nodes in ascending order. And once we've done that, we then attach the smallest nodes to our result list and then move our current pointer to the newly added node. Finally, once all the nodes are processed and the queue is empty, we return our merge list on line 36, which is where we have return dummy head.next, since dummy head is just a placeholder. Now you'll be wondering why we used a queue, and specifically a priority queue. Using a priority queue added a layer of priority management to our queue, which works based on the first in, first out principle, FIFO. This will ensure that we always process the smallest available node first, which is exactly what we need to maintain the sorted order of our merge list. So if you're wondering why we used a queue, and specifically priority queue, there you have it. So at the end of the day, when it's all said and done, this method efficiently merges k-sorted linked list into one sorted linked list using a mini heap, which is very useful for implementing a priority queue. Now let me click run and let's see moment of truth. Let's see if we pass the test cases. You see, we passed the test cases, test case 1, test case 2, test case 3. Pass all the test cases. Thank you for listening. Like and subscribe to the LD's YouTube channel. See you next time. Bye bye.